Hello again. Uh, this is my third video, correspond to the topic of line plot, which is going to be part of the exam as well. So I need you to pay attention closely to this because it's an easy topic, but it requires a lot of attention. So for those students who still don't understand this, and for parents who needs to know what is this topic about, I will give you step by step what is the meaning of line plots, right? So I will start by defining the definitions, of course. I'll give some of the words that you must take into account for the exam and for this topic as well. So I will start defining the line plot. It's basically, I'm sorry here, I'll just make a mistake. It is the scale of the x-axis that represents the data. So basically a line plot is something like this, right? It's a scale, right, in which we use to represent the data that is given to us, right? So that's the definition of line plot. The range. The range is basically quite easy. Once you have the line plot or graphic, okay, it's the difference between the greatest value and the lowest value. So when we're speaking about difference, we're speaking about subtraction, all right? Now we're talking about the greatest value. What is the greatest value here? If we have in the graph or the line plot 1, 2, 3, and 4, we take the greatest value, which is 4, yes, and the lowest value, which is 1, right? And we're going to make the difference here, which is a subtraction. So we take greatest value, 4, minus, which is the difference, 1, which is the lowest value, that's equals to 3. So in that case, the range, it's equals to 3. Alright? Outlier. It is the data value that is not close to the other values. Sometimes in a graphic, when we are getting information, yes, like this or like that, right? We need to notice something here. So if you notice in the scale right here, we have 3 numbers in the information that are very close. We have 1, 2, and 3. Those numbers are close. However, 30 is not close to these 3 numbers. That means that this number right here is the number that is not close to this 3. So 30 in this case, it's the outlier. Right? 30 is the outlier because it's the number that is not close to these 3 values. Notice that the outlier sometimes is not happening because there are graphics line plots in which there is not outlier because the numbers are close in terms of the information, but in this case, just to give the example, 30, which contains the information as well, is not close in the graph to these 3 numbers. So this is considered the outlier. In Spanish, el rechazado. Alright? So please take into account this information. And once you get to write all these definitions, I'm going to give you an example by giving an exercise, right? From the time that we give a data, organizing a data, and designing the line plot as well. Okay? So I'm just going to erase this. If you think I'm going too fast, please make sure to pause in the video, to place stop or pause or whatever. And don't forget to copy or take notes of this. So you can help your your son or daughter, or for the students, is a way to remember the concepts that we saw in class. Okay? I'm going to erase these definitions first. Alright. So let's begin. Let's make an exercise here. Alright. So Imagine that they give me a data. Give me some data. We're gonna call this data hours. Hours that. No, a second, I'm going to use back. So I'm going to call this data hours that students spend watching TV. Alright. So this is the step one. So I'm going to write the numbers of this data as I explained in the previous topic. So I'm going to write the numbers of hours that students spend watching TV. This is correspond to the data as well. So let's see. We have 0, 3, 7, 8, 8, 5, 2, 1, 5, 3, 6, 5, 5, and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the data that we have. So as I explained before, the first step that you have to do here is to organize the data. So this is the first thing you have to do. Let's organize our data. We are going to organize it as we did before, so let's see how it works. Okay? 0, 1, 2, 3, 3, 3, 5, 5, 5, 5, 6, 6, 7, and 8. So this is the same data, but in this case, as you can see, we have to organize it. Alright. Now we are going to proceed to develop the line plot. Alright, so we have to organize data here. Alright. So okay, but this is what you are going to do. You are going to use the numbers unincluded on your line plot. Remember that here you have a scale that must go from 0 to 8, alright? So let's see, I have a 0. Oh, one thing, you have to remember this. In the data we don't repeat numbers, alright? We don't repeat numbers. So for example, so we have 0, 1, 2, 3. You don't do this. You don't do this. In the line plot, you don't repeat the same numbers of the data. So here, you're just going to continue by writing 4. But you are going to ask me, Mr. George, why are you writing 4 in the line plot? It's not in the data, but I recommend you to include it in the scale, right? Because remember that usually in the line plots of scale, there is an order that must go in a systematic order from 0 to whatever number is there. In this case, it must go from 0 to 8. So let's continue. 5, 6, 7, and 8. Alright? So if you notice, the line plot has the numbers from 0 to 8. Sorry about the organization here, because it looks a little bit weird. Alright? Let's see, we're going to have erase a little bit about the data. I just need to organize because I need some space here. Alright? So I'm not going to erase the plot, but but I'm going to write the numbers. I'm going to write the same numbers here, this here, so I can have some space. So 1, 2, 3, 3, 5, 5. Oh, yes. 5, 5, 6, 6, 7, and 8. I have to make sure that these numbers are the same as this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold on. Just gotta make sure that I have the right numbers. No, actually no. Wait a second. Okay. Okay. Let me see. Zero, 1, 2, 3, 3, 3, 1, 2, 3, and 4. Okay. Oh, that's why I forgot to write this up. So here is the same data that I have here. I wrote it here. All right. So now this is the data that corresponds to the line plot. All right. So we're going to call this x equals to students. Okay? And these numbers here are called hours watching TV. Remember that the data is about students that watch TV. So the x that I'm going to draw up here are the number of hours that students watch TV. Alright, so let's see, let's begin. Here, I'm going to start by 0, okay? So how many students don't watch TV? Okay, so this is called 1. How many students watch 1 hour of TV? 1. How many students watch 2 hours of TV? Okay, so just 1. Remember that those numbers here corresponds to the numbers of hours that they watch TV. Alright, so this and this are the same. 3. How many students watch 3 hours TV? 1, 2, and 3. 1, 2, and 3. You see? How many students watch 4 hours of TV? So notice that 4 is not here in the data. So you just skip that number and you get to 5. How many students watch 5 hours? Okay, so you have 1, 2, 3, and 4. 1, 2, 3, and 4. How many students watch 6 hours TV? 1 and 2. 1 and 2. How many students watch 7 hours? 1. 1. How many students watch 8 hours? 1 and 2. 1 and 2. Alright? So notice that this is the line plot that corresponds to the data about the students who watch TV. Remember that this X are the students and the numbers are the hours that the students watch TV. Alright? Any question? Hope no? Alright. So now we are going to find the range. We are going to find the range. Range.